Okay, so you are going to turn to page resource 3.2, and this factoring flowchart has an important step one reminder right at the top. Don't forget to pull out the greatest common factor first. We're going to learn that strategy today. We're also going to learn this difference of squares strategy today. And then in future days, we'll learn this trinomial and box method. So the first thing is, why are we learning these methods? Remember, we're solving quadratics. And so when you solve a quadratic, you're looking for the zeros, the x-intercepts. So this is called the zero product property. Product means multiply. So if the product of two quantities equals 0, then at least one of those quantities must equal 0. So if you have two things being multiplied together, like A times B, and their product is 0, either A has to be 0 or B has to be 0. So these are already in factored form, and we're going to learn how to put things into factored form, but we also need to know, what do we do once something is in factored form? So we are looking to either make x minus 3 equals 0 or x minus 6 equals 0. And you will get pretty good at doing these in your head, but for now you might want to write them out as equations. How would I solve for x? I would add 3 to the other side, so one of my solutions is x equals 3. My other solution, if I add 6 to the other side, would be x equals 6. So this quadratic, if I graphed it, would have an x-intercept at 3 and also at 6 on the x-axis. And that is because when I plug in 3, 3 minus 3 is 0, and anything times 0 is 0. So these are the x values that make this equation equal 0. All right, so we're going to do the same thing in number 2. 2x plus 5 must equal 0, or x plus 1 must equal 0. This is a good example that you'll want to write out using an equation because it's harder to do in your head. So how am I going to solve this? I need to get x by itself. So my first step would be to subtract 5 to the other side of the equation. So 2x equals negative 5. Now I have to divide by 2 on both sides of the equation. So you can leave your answer either as negative 5 halves or that's equal to negative 2.5. Don't forget, you have another equation to solve over here. By subtracting 1 on both sides, you get x equals negative 1. So your two solutions, right, these are connected, the same problem. One x-intercept is at negative 2.5, the other x-intercept is at negative 1. Okay, this one looks a little bit different. This one has just an x and then an x minus 5. So again, you can write x equals 0, x minus 5 equals 0. Set up your two equations for yourself. This equation is already solved. One of our solutions is x equals 0. The other solution, if I add 5 to the other side, is x equals positive 5. So we need the zero product property every time we factor. All right, so this method that we're looking at today is called the greatest common factor method. So here are the steps that you can refer back to, but we are going to find the greatest common factor of all of our coefficients and constants. We're going to find the greatest common factor of the variables. We're going to write our combined greatest common factor from 1 and 2 outside of a parentheses. We're going to divide by the greatest common factor and write the quotient inside parentheses. This will make more sense when we do a practice problem together. So on this first one, I'm going to look at the 2, the negative 4, and the 6. What number goes into each of those equally? 2. I have an x squared, an x, and a constant, so I cannot divide by a variable. So it says to write your greatest common factor outside of parentheses and divide through the original problem by that constant. What is 2x squared divided by 2? X squared. What is negative 4x divided by 2? Negative 2x. And what is 6 divided by 2? 3. So this is called factored form, and this up here was called standard form. We divided out the greatest common factor of 2, and then we wrote what was left inside. Let's look at the next one. What can you divide 9 and 81 both by? I can divide them both by 9. I cannot take out an x because this guy has an x squared, but this guy has no x term. Okay, so now I'm going to divide by 9 for both of my terms here. This becomes just x squared. This becomes negative 9. We're going to learn how to take this a step further, but for now, we have factored using the greatest common factor. All right, I want you to think for a second, what do you think the greatest common factor of 6x squared plus 40x is? What can I divide out? So I can divide out 2x. Both of these are divisible by 2x. What do I get when I divide by 2x? 6 divided by 2 is 3. X squared divided by x is x. 40 divided by 2 is 20, and the x's would divide out. So when you get your factored form, you have two things that you can check. If I redistribute the 2x times the 3x, do I get my 6x squared back? If I distribute the 2x times the 20, do I get my 40x back? And I also want to double check, is there any other greatest common factor that I could still factor out? If you can still factor something out, you didn't grab the greatest common factor. Okay, another strategy that we're going to practice today, sorry for the shadow, is difference of squares. It must have a degree of 2. It must be a quadratic. It must have two terms, be a binomial. Up here, we had a trinomial, we had a binomial. This time, we always need to have two terms. It needs to be a binomial. A and C have to both be perfect squares. Did you notice that the B term is missing, right? Our ABC of standard form, there's no B term in this. So we're going to take the square root of the first and the last term, and those are going to go in our parentheses, and one is addition and one is subtraction. So x squared, that's a perfect square. 9, that's a perfect square. Let's just list for ourselves, what are the perfect squares? 1 squared is 1. Say these in your head. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. Do these seem familiar? 8 squared is 64. 9 squared is 81. 10 squared is 100. You may know 11 squared, 121, and you'd want to know 12 squared is 144. So you're going to be on the lookout for these perfect squares over here in order to use this factoring strategy. All right, so how do I make it look? X squared minus 9. It says let's take the square root, right? We're taking the square root of each of these terms. So the square root of x squared is x, because x times x is x squared. The square root of 9 is 3, because 3 times 3 is 9. And now why is one of them a plus and one of them a minus? So let me show you, you don't have to write this down, but why is it that these two, when you multiply them together, get you back to the original problem? Let's see here. Well, I'll just put small at the bottom here. You don't have to write this. What happens when you multiply x plus 3 times x minus 3 in box? So what happens? I get x squared here. I get positive 3x, but then I get negative 3x, and then I get a negative 9. When you combine your like terms, these two are opposite because of the plus and the minus. So when you add them together, you get 0 as your x term. So x squared minus 9 is what I get when I multiply this back out. And then my second example, I have a perfect square, a perfect square. I'm going to take the square root of those, write my two parentheses. 9x times 9x is 81x squared, and 5 times 5 is 25. One gets a plus and one gets a minus, and it does not matter where you put the plus and the minus. You could put the minus here and the plus here, as long as you have one of each. So, poor planning. On the next page, I forgot that I had actually put a chart for you to write all of the perfect squares. So maybe without looking, pause the video and see if you can fill in all of the perfect squares, just like I listed on the front page to quiz yourself. So we had already written down 1 through 12 on the other page. And then these you may or may not know, but 13 squared is 169. 14 squared, you reverse them, 196. 15 squared is 225. I threw 20 squared in there because 20 times 20 is easy, a 4 with 2 zeros. All right, so now I'd like you to kind of check your understanding. Circle the examples of difference of squares and cross out the ones that aren't. So there's only one difference of squares in this whole list. This first one is a difference of squares. I want you to think about what is wrong with each of these examples. Why are they not difference of squares? So think about it for a minute. And now I'm going to say the answer. 40 is not a perfect square. So I can't take the root of 40 and get an integer. So I'm not going to factor it with difference of squares. Now, difference means subtraction. So if this is not subtraction, I can't use this method. And I want to show you the reason why. What do you think this might factor into? I might guess x plus 3, x plus 3. This does not equal this because when I use the box method, I actually get this middle term, x squared plus 6x plus 9. That is not equal to what I started with. So I cannot factor x squared plus 9. The other thing is, what does this quadratic look like? It's a quadratic that's been shifted up 9. Does this have any x-intercepts? No, so it's not factorable, and it doesn't have any x-intercepts. That should kind of make sense. All right, what's wrong with the next one? It has a subtraction sign. 1 is a perfect square. Guess what? 2 is not in our list over here as a perfect square, 149. I skip over 2. The square root of 2 is not an integer. It's 1.4 something. And what's wrong with this last one? It has 3 terms. I can only use difference of squares when I have 2 terms. Okay, so for a little bit of practice today, we are going to skip ahead to page 302. Page 302, zero product property, GCF, and difference of squares. So first, I'm going to go through and do the odds. Then I'm going to pause the video. You're going to spend 10 minutes or so trying the evens, and then you're going to check your answers. And then you're going to go do today's Google form. All right. First, use the zero product property. Remember, I want this x minus 10 to equal 0. How do I solve for x on this problem? Add 10 to the other side. There, x equals 10. I'm going to skip the even for you to come back. On number 3, I'm going to write 2 equations. X equals 0 or x plus 4 equals 0. That is already the solution. This I would have to subtract 4. So x equals -4. I'm going to skip number 4 for you to come back to. All right, number 5. This 2, I'm just going to ignore. Can the number 2 ever equal 0? No. It has to have an x outside the parentheses if you're going to talk about it. So I'm going to skip right here. 4x minus 2 equals 0. 2x plus 4 equals 0. How do I get x by itself? Add 2 to the other side. 4x equals 2. Divide by 4. X equals 1/2. Subtract 4 to the other side. 2x equals -4. Divide by 2 on both sides. X equals -2. Those are the hardest ones that you're going to have to solve when there's some fractions involved. In a minute, you're going to come back to 2 and 4. All right, factor using greatest common factor. Let's skip up here to number 7. What can I divide both of these by? I can divide them both by 9. So if I factor out a 9, I would have x squared minus 9 left. This example can go one step further. So let's recognize that this is a difference of squares right here. So a difference of squares, I can take the square root of both of these terms. I get x and I get 3. And remember, one gets a plus, one gets a minus. So this was a two-step factoring problem, solved with greatest common factor and difference of squares. If you notice, there's no equal 0. So up here, we were solving for x. Here, we're just practicing factoring. So you can do 8. What can I divide out of number 9? I can divide everything by 3. So if I divide everything by 3, go ahead and try this problem if you want. See if you can write your new trinomial in the parentheses. I would have x squared plus 2x plus 3. And on number 11, what can I divide out from both of those terms? A 9 and an x. So I'm going to divide both of those by 9x. 9 divided by 9 is just 1, and then x squared divided by x is x minus 2. You can double check and use the distributive property. See, I would get 9x squared back, and I would get negative 18x back. Let's see, number 13, solve the following quadratics. So this is either a difference of squares or greatest common factor. I think all of these are greatest common factor. What can I divide by on both of these? I can divide out a 6x. See how they both have a 6 and they both have an x? What do I get when I divide by 6x? I would get 6 divided by 6 is 1. X squared divided by x is x. And then anything divided by itself is 1. So I actually have 6x times x minus 1 equals 0. I need to finish this problem either 6x equals 0 or x minus 1 equals 0. We know that 6 times 0 is 0. I could also divide by 6 on both sides and prove x has to be 0. And on this one, maybe you can do it in your head. X would have to be 1. You're going to come back and do the evens. And the last couple problems are all factoring using difference of squares. But if they're not factorable, we're going to write prime. Prime means it's not factorable. So I'm going to go through and do the odds, and you're going to try the evens. First I have to double check, is this a minus sign? And are both of these, the 1 and the 49, perfect squares? Yes, they are. So then I write 2 parentheses. 1 gets a plus, 1 gets a minus, and I take the square root of the original 2 terms. So x times x is x squared. 7 times 7 is 49. In 17, there is a minus sign. This is a perfect square, and this is a perfect square. So I can do this problem. 1 gets a plus, 1 gets a minus, and now I'm going to take the square root of 100, so that's 10x, 10x. Square root of 1 is just 1. So 10x plus 1 and 10x minus 1. There is something wrong on number 19. The plus sign makes this a prime. There is no way to factor that problem. All right, number 21. Solve the following quadratic equations. So I'm looking, there's a minus sign, and there's two terms, and they both are perfect squares, the 1 and the 64. So I write my two parentheses, 1 gets a plus, 1 gets a minus. I take the square root, x times x is x squared, 8 times 8, 64. I have to solve this one because it says equals 0. So once I factor, I have to solve. So x plus 8 equals 0, x minus 8 equals 0. So x is either negative 8 or positive 8. So you're going to go back through, pause the video now, and try all the evens, and I'll come back on with an answer key for you to check your work. But please take the time to try the evens first. All right, you should already have these solved. The first, number 2, x would either be negative 4 or positive 3 when you set each of those equations equal to 0. I'm going to write out number 4 because this one's a little bit tougher. 3x plus 2 equals 0 or 4x minus 1 equals 0. The first step would be subtract 2 to the other side of the equation. So 3x equals negative 2. Divide by 3 on both sides of the equation. X is the fraction negative 2/3. So on number 4, add 1 to the other side of the equation and divide by the 4. So x is the fraction 1/4. So these, we got non-integers, but those are the x-intercepts for this problem. Skipping down to 6, we're looking for what can we divide each term by? You should have divided out a 2. And what would you have left? X squared minus 2x plus 3 would be left. On number 8, I think we already did a couple of these problems on the resource page. I'm going to divide by 2x, so I would have 3x plus 20 left. I'm going to divide by 5 on this example. So 2x squared plus, let's see, if I divide by 5, I would have 4x plus, I should be writing this, but I'm dividing by 5. Anything divided by itself is 1. Now I have to take out the greatest common factor and solve. If I divide them both by x, I should get x times x plus 5 equals 0. So either x equals 0, or I think you know by now that x would have to be negative 5, because negative 5 plus 5 gives me 0 for the zero product property. Let's see, on 14, you should have factored out a 4x, and then you'll have x plus 10 left. So x is either 0 or negative 10. And on the back page, let's see, you had to factor using greatest common factor. So you should have done x plus 2, x minus 2, 3x plus 8, 3x minus 8, and the 2 makes this prime. It is not a perfect square. And on this last one, 2x plus 5, 2x minus 5. I'm going to write this one out using the equations. And if you did not get a chance to try solving it, I'd like you to try solving those two equations before I put the answer up. So subtract 5, 2x equals minus 5, x equals, I'm going to write it as negative 2.5 because I recognize that fraction. And on this one, you would be adding 5 and then dividing by 2. So you would also have positive 2.5 as your other answer. So now that you've completed today's notes, you have homework 3-1 that is due tomorrow, and you have a Google form to complete to finish your attendance for the day. Please reach out if you have questions.